Hello everyone, my name is Angie Poggi, and in this video I'm going to give you a brief introduction to biostatistics. We're going to learn what biostatistic is, why it is important, the types of variables, and the types of studies. Biostatistics is a science that applies a set of tools and techniques that are used for collecting, describing, organizing, analyzing, and interpreting data or information to assist in making informed decisions that may impact people's health. Biostatistics provides important information on the study of diseases and conditions affecting groups of people. Using biostatistics, researchers or investigators design experiments to collect data, organize the information, and provide possible solutions to health problems based on the data collected. Through biostatistics, investigators can gain a better understanding of determinants or factors that may contribute to the development or progression of health issues. Therefore, biostatistics is important in the advancement of knowledge in biology, clinical in medicine, health economics, health policy, and other disciplines. Biostatistics is used to describe distributions of data, estimate parameters, hypothesis testing, prediction, and survival analysis. Now let's discuss the types of variables. A variable is a characteristic that can be measured from individuals or group of interest. Examples of variables are age, weight, sex or gender, and place of birth, among others. Random variables are variables with undefined values which can be determined using probability, so these variables are associated to a probabilistic distribution. And there are two types of variables: qualitative and quantitative variables. Qualitative variables are those characteristics that can only be categorized and cannot be used to perform mathematical operations. For example, the variable sex is qualitative because the attributes are female or male. And we cannot add female plus male, right? It doesn't make sense. Qualitative variables can be nominal or ordinal. Nominal variables are those with categorical attributes, and ordinal variables are those variables with categorical attributes that can be ranked. Examples are sex or race for nominal variables, and ordinal we can mention levels of education, which can have attributes such as elementary school, middle school, high school, college, graduate. You get it now, right? It's just a rank in order. On the other hand, we have quantitative variables, which describes attributes that can be measured and can be used to perform mathematical operations. Quantitative variables are then classified into other categories: discrete or continuous variable. Discrete variables are those with integers as values, no use of decimal points. For example, number of children in a household. We cannot have 1.5 kids, right? So continuous variables are those with infinite numbers in between or decimal values. For example, weight is a continuous variable because a valid value for weight is 135.7 pounds. Continuous variables are coded into rank or categories. For example, the variable age. What is your age? You will answer with a number. Or we can collect the data in categories such as under 21, between 21 and 65, and over 65 years of age. Or we can also ask which category best describes your age. Are you a teenager, adult, or senior? Before introducing types of studies, we need to discuss sampling. Collecting data of every individual in our population of interest can be time-consuming and very expensive. Therefore, it is feasible to apply sampling methodology to collect data on a subset of individuals of our population of interest. So let's say we want to study the distribution of factors of obesity in the state of Florida. It will be burdensome to collect data for 21.4 million people living in Florida. So sampling methodology allows us to obtain data from a subset or group of people in Florida to describe the distribution of obesity in Florida. A random sample is an independent selection of some members of the population with non-zero probability of being selected. In a simple random sample, each group member has the same probability of being selected. Although there are many concepts about sampling methodology, the goal is to have a representative sample of the population in order to have an accurate estimate or inferences about the population. When we want to learn about the relationship between an explanatory variable and response variables, or a factor and health outcome, we must conduct comparative studies. We compare groups in order to determine that any differences between them are due to the explanatory factor. The effects of a factor can be judged only in relationship to what will happen in its absence. For example, if we want to understand the relationship between exposure to air pollution and lung cancer, we will want to compare two groups. One group of people who have been exposed to air pollution and another group with no exposure to air pollution. To determine the effect of air pollution on lung cancer, we must ensure both groups are very similar in terms of sociodemographics, that is age, gender, profession, and other factors such as smoking status, to effectively determine that any differences are due to the air pollution. In non-experimental studies or observational studies, the investigator only classifies individuals as exposed or not exposed, without any intervention. In experimental studies, the investigator assigns the exposure to the one group while leaving the other non-exposed as a control group.